Welcome to part 1 of integrals by trigonometric substitution. In this video we're going to talk about why this technique works, and we're going to solve one example. So to understand why we need to learn about trigonometric substitution, let's say that we want to find this integral. This integral you won't be able to solve using the previous method we learned. If you apply U substitution, you won't be able to solve because here you have x squared and here you don't have an x. But well, the idea here is that if you look at the denominator, you'll see that it looks similar to a trigonometric identity. What I'm talking about is this. If you look at this basic trig identity, that is cosine squared is 1 minus sine squared, you'll see that this side of the equation looks very similar to this expression in the integral. So we're going to try to make this substitution. We're going to make x squared equals to sine squared of t. X squared equals to sine squared of t. So that means that x is sine of t. Okay, that is x, but we also need dx. We also need to substitute dx. So to find the x, we take the derivative of x with respect to t, and that will be the derivative of sine of t, that is cosine of t. So that means that dx is cosine of t dt. So if we make that substitution in our integral, we'll get this expression. Here dx is cosine of t dt, and 1 minus x squared is 1 minus sine squared t. So here we have an integral in the variable t. Here t is the variable we just introduced, but here 1 minus sine squared of t, that's square root of that is cosine of t. So we have cosine of t over cosine of t, and those cancel out. So we get simply the integral of dt, and that equals t. And this looks like we're done, right? Well, the only thing that is left is to substitute back the variable t for the variable x. But how do we do that? Well, we have that x is sine of t, so that means that t is arcsine of x, just the inverse trigonometric function. So replacing the t here for arcsine of x, we get the final answer. So let's talk about why this technique works. And well, trigonometric substitution allows you to simplify radicals. There are some cases that you can apply this technique when there are radicals in the expression, but normally there are radicals. And the idea is that these identities allow you to transform sums or differences into some function squared, some trigonometric function squared. So if you have the square root of this, if you replace this for this, you get the square root of something squared. And this is the second identity that is useful. You use this identity when you have a sum. So there are three basic cases where you can use trigonometric substitution. And the first one is when you have a squared minus x squared. You have an expression of this form. Here a squared can be any number, can be 4 for example. So in this case you use the substitution x equals a sine of t. This is what we did in the previous example. And if you do that, you'll get that this expression will be a squared. Here you can factor a squared, right, and you get 1 minus sine squared of t. And 1 minus sine squared of t is sine squared of t. The second case is when you have this sum, you have a squared plus x squared. And here the idea is to use this identity. So you take x equals to tangent of x, or tangent of t, and if you didn't do that substitution, you get that this is a squared 1 plus tangent square of t, and according to this identity, that is a squared secant square of t. And the third case that is similar is when you had this difference. You have x squared minus a squared, and in this case you'll also want to use this identity, but here you choose x equals to a secant of t, and if you do that, you get that this equals a squared times x squared, that is secant square of t, minus 1, and that is s according to this identity. If you subtract 1 from both sides, you'll get that this equals tangent square of t. So these are the 3 basic cases, and in the following parts we'll solve more examples of integrals by trigonometric substitution. That's all for now. Thank you for watching, and see you next time.